Now we look at reflections of graphs. A reflection of a graph is when you multiply a graph by a negative, in this case -1. So we would be looking at the graph of y equals x squared, and y equals the opposite of x squared. When I graph y equals x squared, of course we've been graphing that on the last few problems, there's my parabola. But when I graph y equals -x squared, that's going to be the graph down here. Now if you put them both in your y equals screen, like I did, when you press graph, it will graph the first equation, y1, first, so you can see what it looks like, and then the second equation in y2. So let me try that again so that it won't show them both to you at the same time. There's y1, so there's its graph. Now let me go back and put just the opposite of that in. Same equation, I'm just going to have a -1 in front of it. That's how you take the opposite of something. Now if I go to graph it, the first graph was already there, so we see the second graph is the down here part. It's not really one graph, it's two separate graphs. That problem I did corresponds to this one down here. If you just change the sign in front of the function, I graphed a square root of x plus 3 and then a negative square root of x plus 3. The first graph was this one on top. The second graph was this one on bottom. I'm going to do it a little darker so you can tell the difference. Now, if I do the same thing with the absolute value function, I type the absolute value function. Well, actually, this is a little different. If instead of putting the negative in front of the entire function, I just put the negative in front of the x. See here, I didn't put a negative out in front. That would have just flipped the v down to the bottom. Here I put the negative in front of the actual x and only in front of the x. When you change the sign only of the x, that's going to result in a graph that has been reflected, just like this one was reflected, a mirror image there. It reflected it down here, but it's going to reflect it over the y-axis on this problem. So when you change the sign of the y, it reflects your graph across the x-axis. And when you change the sign of the x, it reflects the graph across the y-axis. The first graph is y equals x plus 3, is this one. Absolute value of x plus 3, I'm sorry. And when I reflect it around the y-axis, that's going to flip it over here and give me this graph. Now if we look at an application here, we can kind of talk about shifts a little bit in this application. Wright Sports Management sells elliptical machines, and the monthly profit from these machines can be modeled by P of x equals negative x minus 55 squared plus 4,500. So here notice how this negative is just in front of that squared part, and then you have your 4,500 that's stuck off to the end. So each part of this is a translation or a modification to where the graph of that equation goes. Here, x is the number of elliptical machines that are produced and sold. So let's look at the graph of our basic function, which in this case would be y equals x squared with the negative in front of it. Okay. So we know that graph is that regular upside down parabola, just like that, a little rounder. The negative in front of it is what makes it go down. Okay. The minus 55 is going to shift it in the positive direction, so it's going to shift it 55 units to the right. And the plus 4,500 is going to shift it up 4,500 units. So that means instead of the vertex being down here at 0, my vertex is going to go over 55 and up 4,500 units to where my vertex is now located here. So it shifted 55 units to the right and 4,500 units up. Now question B says, how many elliptical machines must be produced and sold to yield the maximum monthly profit? Well, my graph is the profit graph. So if I want the maximum, that means I want the highest point. The highest point on this is at the vertex. My vertex in this case is when x equals negative 55, I'm sorry, 55. And when x equals 55, my y is 4,500. So the most profit will be made when 55 machines are produced and sold, and it will result in a profit of 4,500.